Hi, and welcome to the latest devlog for Toast Engine. My hobby-built game engine focused on large-scale planet rendering. At the same time, I'm developing a game called The Next Frontier, where the goal is to let players colonize and eventually terraform Mars. This is actually my first project in both graphics programming and game development, so a big part of this journey has been learning by doing. I've been working on it for a couple of years now, alongside my regular job, which means progress is steady but not rushed. These devlogs are my way of documenting that journey and sharing the progress with you. There is no fixed schedule, I release them when there is meaningful work to show. If you enjoy following long-term engine and game development, consider subscribing. Now let's dive into the latest updates. So first off, in devlog 8, I want to talk a bit about Asset Manager that I've just implemented. And it's basically to complete the pipeline for assets that you add to the game. So if we go to the content browser now, this will only now display the project folders, and you will have to add assets to this. And I've done it only for textures, and that's textures 2D. And you can see they're now displayed as actual textures instead of just a plain text file icon that I had before. You saw here we have an asset registry. So yeah, most of this is back-end work, but I've done some things that I can show you. So basically now when you want to try something, if we go to the, let's say we want to use a different and this here you can pick from anywhere on your computer. So here we can get one of the old textures, let's say the red one. You get this prompted this, and you can you need to say if this is a color data or not. Basically I have some work to do here in my render, but that's a different story. And here in the future I would like to have like a preview of how the texture would look when you import it, and with different settings as well. And we're not going to import it right now, but what would happen if we imported it would be that it ends up here in this folder where the rest of the textures are. I have a special folder for UI textures, and then it gets put in the registry, and when I close the project or save the project, that registry getting serialized, and then when I open up the project again, it gets deserialized. So I'm always tracking what kind of assets are in the project as of right now. And eventually I'm gonna have some kind of like Blender have some cleanup where you can clean up things that are not currently in use, like materials that aren't used, for example, in your project. And I've done this for textures only right now, but I'm gonna add like material, meshes, audio, fonts, like everything is going into this asset manager. And then when you want to build your game, I have a new button here down to the left you can click. And if we go to the console, you see build game. And then I wasn't at the bottom here, but you can see here that the latest we can rebuild the game again. And you can see it takes all the asset in the asset registry and bakes them into a binary format, because like other games or real games, you can't just go into a texture and change the texture itself on your computer like you. They are binary format, and this is what I'm doing as well. So you can see here I'm taking the Starfield map, which we can see if we press play and move out. Here's the Starfield map. It takes that and creates a binary format from it, and it's called T asset, T for toast. And it also does, the registry is also moved into a binary format. And it's hard to show you, but I prepared like hex editor, and I can open up here, and here you have all the data. This is nothing, tells nothing to the user. Basically, it's just a bunch of data, and hopefully when I deserialize this during runtime, it's gonna work, and it's gonna be the texture. So instead of using the actual image file, it's gonna be a binary file. So that's like when you build the game or export the game, then all the assets will be done into binary format. And there's a header first, which basically say that this this asset is a texture 2D, or this is audio, or this is a material. So, but they are going to be in binary files, and some engines, they pack them all into one, but you can just the same pack them into several. And I've started with that at least, and we'll see how we end up, or what we end up with. So yeah, asset manager done. It's something I prepared for a while, and I think it's that's one step closer to actually being able to export the game. And I plan to hand it out to friends first from a USB stick eventually. So yeah, onwards to the next step. It is March 31st, and I've just finished implementing air resistance to my physics engine. It's just a basic implementation. I do rough estimate that we're gonna talk a bit more about. But to test this, I've added 2 starships. One I call version 4, and one is air resistance, but it's basically the same mesh. They are both high up in the air here, 5,000 meters up. The rigid body have some new values. We have drag coefficient, and we have cross-section min and cross-section max. And these two, the last two here, are the ones that I talk about when I say it's an assumption. So this is basically just for cylinder. The angle of attack decides the actual cross-section. And if it's standing up, it's 50. And if it's falling, laying down, basically, falling belly first, it's 500. So the test here is standing up, so it's falling with the bottom first, and then to the left here we have Starship version 4, which is belly first. So the idea is that the air resistant, without air resistant in a vacuum, these ones would basically fall at the same speed. But here, now when we are testing it, we're actually gonna lower this to 5,000 because it's easier to test. You see that they are gonna fall at different speed depending on that they have a different cross section towards the airflow. So this one to the left here is gonna have more lifting capability, or cross range. Sorry, not cross range, that's the wrong word. It's gonna have more area towards the air flow basically, which is gonna lift the body, so it's gonna fall slower. We also have a few, look at the other one, we have a few debug values here. The drag force, so basically this is the force acting upon from the air resistance. So the faster it goes, the higher this will be until it reaches something called terminal velocity. We have an air density, which is, of course, we're talking about Mars here, so it's a lot thinner atmosphere, but there is an atmosphere. We have the actual effective cross-section, so this is gonna be 50 for the right one and 500 for the left one. We have the altitude, and we have the velocity it's falling, or the linear velocity. So this is the velocity it's falling. So if we press play now and look up into the air, and we can target our air resistance one. We've lowered the mass just to make it easier to see. But we can see here that it's falling, have a drag force acting upon it. You can see it have 50.2 square meters. Linear velocity is 70 now. If we looked at Starship version 2, who's gonna fall slower, we have only 55. And we have a drag force acting upon it that is higher than on the one here, because it has more cross range, so it's more than double we have here. And you can see here now we're looking at the one falling fast. Its linear velocity is 132. Starship version 4 is only at 56, and it's basically reached terminal velocity. But we can see the other one falling in here. It's not gonna hit the ground because it's no. But this one is still falling. So this proves out that air resistance works. As I've said, in the future we're going to, or I have to add more when it comes to flap. I want the flaps to be able to control how it steers through the atmosphere and so on, to come to a precise landing. But this basically proves out my theory. And I also lowered it to 5,000 kilograms or 5 tons instead. Like the idea when they land is gonna be, SpaceX say they're gonna land like 100 ton on Mars or something like that crazy. So it's gonna be a lot higher. It's just easier to show you the effect of the air resistance if the mass is a bit lower. Otherwise it falls too quickly and they basically go below the surface. So with that now done, the upgrade to the physics engine in this release is done as well, which is yeah, it's great. Moving forward to terrain materials and the planet materials and whatnot. It's May the 8th and I've spent the last couple of weeks developing my new terrain system, or an upgrade to the planet terrain system. The colors are a bit different, and that means I've done a lot of small changes as well, so I can't really replicate what I had before. But this is the planet as we had without any enhancement system that I've added. And you can see if we zoom out, you have the albedo map. This very reddish. I can explain why later. We go back down, fly down to the camera again. Camera over here. And the first thing I did was that I implemented a wall enhancement. If we go in here to the planet pop-up and the terrain data, you can see we have a lot of extra things that we're gonna go through. We have wall enhancement, we have erosion, and we also have PBR materials for the terrain. So in terms of wall and erosions, they are completely new, while the materials I used to have before, but I've enhanced them and made them better basically. So we have now different material for different areas. So yeah, we'll go into details later on, but we're gonna start first with the wall enhancement. And with my height map, each pixel of the height map is 2.5 kilometers. So if we look on the height map, this is my height map, it's 8K. And if we start zooming, we can see the pixels starting to appear. Each pixel is a height value that we use in Toast Engine to create the environment or the terrain that you're seeing. If we zoom far enough, we'll get down to 2 pixels. But this is still 2.5K of the terrain of Mars. So while the height map is telling us that the black line is the height and what we're seeing here between 2 pixels, in reality it could be the red line, where something that looks like a very long slope is actually a very steep cliff. And what happens is that we get very flat, or we don't get very steep terrain. So for example, if we fly up, actually what we do, we're gonna go into play mode here. It's gonna make it a lot easier. And we can travel to somewhere, like if we look here, it should look steep, right? This here should look steep, but it won't be. It will still look like this, no matter what. And that's because like the height map can't show more details than this. There are some solutions. We'll talk about virtual textures in the future. That's my next step. But like this should be a cliff, right? But it looks more like a slope. So what I did was I did something called wall enhancement, which basically I find a slope, and if the slope is at a certain angle, I make it steeper. This makes me lose some of the slopes that actually are slopes, but I think it looks more dramatic with a wall instead. So if we activate the function, you can see this is what we get. And you can see it's a more dramatic look now compared to old one. And I mean, I can change settings here, how it's sharp and to start, and tweak everything. The max delta. There's a lot of different values here. The slope can end. If I go below slope start, and this happens. So there's a lot of things I can play around with here. And I'm gonna look into this more into the future, because I wanna also, like you could see, the normals aren't really behaving as I would like them to be on that distance. So there's, but I think overall it makes a cliff actually becoming a cliff. So if we zoom out and then we go down in here, you can see that actually is a cliff now. So that is the first thing I did. I love it a lot. Makes me want to fly around and just check out the different cliffs. The second part I did was Erosion, that I built, and I followed a really good guide that had or a video. I'll link it down below, and it actually had a shaded toy link to it, and yeah, it does so much. We can see if we can find some a good spot for this. Let's say that we go here. There's actually some normal bug, nice. But you can see our wall as well here. Enhancement does this. If we enable erosion now, it does this kind of like as if water has flown down here once upon a time. You can also see that it's starting to become really laggy as well. And that is another thing now. For the first time ever, I'm actually hitting some kind of limit where I need to do optimization. So as part of my next release, I'm gonna do a lot of optimization, trying to get the rendering speed up, because I really want to have this kind of system included in the engine. And you can see as we zoom out, they're actually faded out. Fly down again, then we can see. And I think, I think it does a lot. If we go back here to the starting area, and we look at like a distance here, if we turn both off, this is what it looks. You can see erosion does quite a lot to making the terrain interesting. And here as well, there is a lot of settings. You have a max distance, erosion strength, and as well, like these settings can be and will be played around with, and I will make them. You can see the erosion strength changes the height of the erosion. So there's a lot to be played around with here, and the system can for sure be improved. The normals can be improved linked to these systems. But yeah, I mean, it does a lot for the terrain, especially on a distance. If you're up close to it, kind of looks that it needs some work. But I wanted to try it out and see that it had some effect, and it for sure does. Like if we look here, this looks a lot better than it used to do. It uses a slope value as well, so if you have a slope, then it adds erosion basically to it. But it takes up a lot of performance, as you can see. So I need to optimize this, but it looks a lot better than it used to do. So I'm really happy with this. It went fairly quickly to set up as well in comparison to what I thought. We also, you can see we have the stone backs. This is actually icosphere mesh, which didn't used to have the stones. It was the geometric clip mapping that used to have that, but it's back now, and I'm also thinking about removing geometric clip mapping altogether. It was a sidetrack that teach me some lessons, but I think icosphere is the way I want to go forward with this. It's the same as like in the beginning of this engine, I used to support several graphic interfaces, which just takes a lot of time for a single developer to do that, and it's not really worth it, is the feeling I'm getting from this. Okay, the last one, which I think is gonna do a lot here. Oh, here comes the ship landing. It's gonna do a lot for the close-up terrain here. We enable terrain materials, and you can see it completely changes everything. And this is it's not perfect for sure, but it looks a lot better than this. A lot. I mean, it makes the surface a bit more interesting. It makes actually like the stones here looks good, like the stone does something. But when you do this and now we add stone, the stones looks weird. So I'm gonna have to do something about the stone, making them use PBR material as well, most likely. But in terms of look, I think it looks a bit repetitive maybe up here, but I have something to, like I have some ideas on how to solve that and make it a bit more irregular. But down here it looks amazing. And this is the gravel material. We can see we have several planets material here, and all of these materials need some work. But in this version of the system, I just wanted to see that it was possible. I use Substance Designer to create these materials, and I can always improve. Like, it's a new software for me, and I need to go over and iterate over it again for sure. But so we have rock cliff here, and you can see they have albedo, normal, roughness, ambient occlusion, and displacement mapping. It's only basically these first 4. I don't do any height displacement from these maps. On top of that, these ones have noise layers as well. And we used to only have fractal noise. Now we have ridge, turbulence, and Voronoi as well. And there's a lot of things I can do with this in the future to make the terrain look better. I have a debug color to choose, so we can see, like, if we press stop here and we can go into planet materials debug, these are the materials that are actually being used and they're blended together. So I can use that to play around as well, makes it easier for me. So the materials we have: rock, cliff, gravel. Gravel is what you're looking at mostly. This area is dominated by gravel. But then we have sand, flat, and sand erosion. And all of these, like the sandy ones, sand and sand erosion, they both have the same material, PBR material, but they have different noise layers. So all of this combined creates the final look and feel. So if we move over here to something a bit more steeper, maybe, where were we before? Here we have something, maybe can we find some cliffs, maybe? Yeah. And you can see here the blending between the colors of the material is not really perfect. So this is what I'm saying, like I need to learn myself how to make correct materials. But you can see they have a different albedo texture and different roughness. So yeah. But it's, as I said, I just wanted to show to myself that I could do it. And then I can always improve later at a later stage. And actually, if we are going to find sandy area, I think we need to do this. Because this is, I found this the tricky part to find different areas actually. Let's see, do we have sand somewhere? What we can do here is, between gravel, we can do the, I think, blend sharpness. If we drive that up, we might, yeah, we're gonna see different. That one, and then sand erosion. That one. See, we can actually also, if we rotate the planet, it's gonna be easier. Let's see if we can find. Yeah, here we have some sandy areas. Go back to where's the camera? Let's lower the planet a bit. Like that. Let's see if we can fly over there. We can actually, I think, do like this. Yes. Let's fly over here. See if we can find some sand, and here as well, like this needs more work, but it's a good step in the correct direction. Like, you know, every time I do something I try to improve it. And here we have some erosion, and we can go down, and we also have, we should have some, yeah, there's some, but we should have some rolling hills here, more like sand dunes. Maybe if we change the sunlight, I'm not sure if we're gonna be able to. Yeah, we can see the they actually have some kind of dune noise instead of normal. But as I said, I mean, this is a work in progress. It looks better for sure. The planets are definitely more interesting to look at, but this is something that I will have to keep working on as I go with the development. But you know me, I never do something 100% straight away. If I can get 75% or 50% in the right direction in one go, then that's a win basically, because next time I go back I do 50% again, and eventually that gap will goes lower and lower. Yeah, here we are back. So overall I'm really happy with what I'm seeing here and how it's looking. Next thing, like at the end of this, I started researching if I could get a higher detail level by using something called virtual texturing. So that is something I'm gonna look into in the future as well, to do virtual texturing of the surface instead. And the hope is that that will enable me to use higher height map, and then the erosion filter might just do the final details instead of doing all the erosion, for example. So I have plans, but for now this looks a lot better than the old system. You have to agree with me on that. Yeah, so this is the last for this development log, and in the next one we're gonna finish up version 0.4 it is, and move on to 0.5, which is actually pretty huge. I've added more and more stuff to it without realizing how much I've added, so we're gonna have to bit by bit on it. Yeah, thanks for watching, and I'll see you in the next video.